Our friend Vishal Thomas is going to give us an update on everything Clemson. Let's roll.
Well, thank you very much for that, man. Thank you very much. You know, folks, I did my PhD here in the bioengineering department at Clemson. And if I may offer you a little bit of a backstory, before Clemson, my undergrad and graduate degrees were both in mechanical engineering. I had very little exposure to the world of medical devices, almost none at all. Mechanical engineering, it was my bread and butter. I loved it. I lived it. In fact, some of my friends, they said that my personality sometimes bordered too much on the mechanical, that I tended to come off as automated, robotic at times. My best friend, he had a name for me, the ideal machine. I loved it and hated it. Loved it because he called me ideal. Hated it because he called me a machine. But I digress. At one point, I got the opportunity to be part of a medical device startup. And that experience, it sowed a seed of interest in the bioengineering field for me. And so when the opportunity came, I decided, hey, I want to do a PhD in bioengineering. I feel like the field is calling to me. So I came over to Clemson and I joined Dr. Jeremy Mercury's lab. And folks, let me tell you, he's an awesome guy, just plain awesome. I had the best PhD experience during my 6 years with him. I was almost sad when it was over, and they told me I had to graduate. Like I just couldn't stay there anymore. So, but it was a heartwarming moment. And folks, during my PhD, I had the pleasure of taking one of his classes, the Preclinical and Regulatory Affairs for Medical Devices. And listening to him teach, I remember thinking to myself, my God, I love this. I love how he explains the whole medical device pipeline. This is just fascinating stuff. But you know what? The most interesting part about that was that of everything that he taught me, the thing that I ironically found the most interesting was that in every stage of the medical device pipeline, there was a lot of documentation that you had to maintain meticulous records of everything. The paperwork was the part that fascinated me the most. Jeremy said I was crazy, but for my students, a well-written document is the way into my heart. I'm weak at the knees when I see something that's really incredibly well-written. It's my weakness. But after taking that class, my department, they offered me a chance to become a teaching assistant for our senior design program. And for those of you who don't know about that program, it's a 2-semester class that trains our senior students on how to identify an unmet clinical need, design a solution around it, prototype it, and test it. The program's been around 2011, and let me tell you, every single year since then, our students have either won or placed at every national or regional competition they've entered in. You name it, we've been there. ACC Inventure, Venture Well, the Johns Hopkins Design Competition, Engineering World Health, the Collegiate Inventors Competition, PDMA Carolinas, PDMA International, NIH Debut, all of them. In fact, our most recent crop of students, they actually won a $15,000 NIH debut award in the field of women's health for developing a novel intrauterine device. They're working on a patent for that device right now. We're very proud of them. So you might well ask, well, how do we do it? How do we get our students to do so well? Well, you've probably heard it takes a village to raise a child sometimes. In our case, it takes a whole department and more. So here's how it works. Whenever our students are called to present, we make a call out to the entire department. We tell our faculty, hey, our students are presenting. Would you like to come sit in and offer feedback? And so we get the whole crop of teaching assistants, faculty mentors, clinicians, industry partners, and sometimes even their parents. Everybody comes in, everybody pitches in. So our students get feedback from so many diverse perspectives. We teach them how to frame the problem, pitch a solution, and articulate the value of that solution. That's what we do. We teach them how to do a pattern search, market analysis, and we sometimes even ask the launchpad to send a few investors our way so that our students can learn what it takes, what an investor wants to hear out of a pitch deck. Now do you see why we do so well? The man in charge of the program, Dr. John Desjardins, he has been incredibly gifted in the design field. But I hear he's stepping aside from the program next year. So as faculty now, I think I have some pretty big shoes to fill. It scares me, but I think I'm up to the challenge. Now, that being said, our senior design program, it produces some of the finest crop of industry-ready graduates. But we have another crown in our jewel, and that's the Master of Engineering program. Dr. Jeremy Mercury and Dr. Larry Boyd, they're in charge of the program now. And let me tell you, they take the rigor of the senior design program to another level entirely. But I won't steal their thunder. They'll talk about it. They have something wonderful lined up for you. So they'll talk about it. But another couple ways where we add value to our students is, see, we have something called the medical device reprocessing program, where students get to learn how to take a used medical device and find new life and uses for it. We have an orthopedic medical device product specialist certificate, where students learn about the life cycle of a product. We even have a quality science certificate for students interested in learning about the quality side of things. And best of all, very recently, Clemson got awarded a $20 million grant from the NSF to partner with industry and develop AI-enabled healthcare devices and train an AI-ready workforce. And so with that, I rest my case. With everything that I've given you, what do you think about the state of medical device education at Clemson? It's excellent. Well, thank you.